Good morning. So today we're going to be talking about cones and spheres. On a cone, it has one circular base and one vertex. Remember, a vertex is the point, okay? And it has one circular base. A point and one circular base. You can have an oblique cone, that means it's just slanted, and then a right cone. The altitude has one point at the vertex and the other one is perpendicular to the base. So if we're talking about the height, we're talking about the point that goes from the vertex straight down and forms 90 degrees. From the point straight down and forms 90 degrees. Yesterday when we were talking about the pyramids, that was the brown stick. If you remember the example that I told that the height is the brown stick of the pyramid. And then the slant height, remember this is just like on pyramids, the slant height, they're going to label it with a cursive L, is a segment from the circumference of the base to the vertex. So this is the slant, okay? The slant height, this is the slant height right here. That's going to be that crooked side. So if we're going to find the lateral surface area, just like on a soup can, it's the label. The surface area of a cone is everything except for the circle. And the formula for that is pi r L. What does the R stand for? Radius. And that little funny looking L is the slant height. Very good. So this right here is your radius. And this is your slant height. And again, remember that what happens inside are all those little triangles. So on this first one, if I'm trying to find the lateral surface area, it's pi r L. So pi, my radius, would be 3. And then my slant height is this one right here. But what I do have is a right triangle. So 4 squared plus 3 squared equals c squared. 16 plus 9. That gives me 25, and I have to take the square root. That means that other side over here is 5, so my slant height is 5. So that would give me 15 pi, which gives me 47 point, and it says round it to the nearest tenths, so 47.1 centimeters squared. Okay, over here on this one, my lateral surface area is pi r L. My radius is 9, and my slant height is 15. So pi 9 times 15 gives me 424.1 centimeters squared. So that's the lateral surface area. That's just the edge around the cone, not the circle. So what if I want to find total? The only thing I need to add is a circle. Well, this is like the big B. Okay, this is like that big B we've been talking about. So for the total surface area, it's pi r L, which is the lateral surface area. And then I need to add the area of a circle because I only have one. So pi, my radius is 9. But here, this is my slant height, so I'm going to have to do Pythagorean theorem. This would be 81 and 144. That's 225. And so the square root of 225 is 15. So that means that my slant height is 15. So this is pi 9 times 15, which is 424 centimeters squared. Oh wait, that's just the lateral. So now I have to add pi 9 squared, which is 254.5 plus the 424.1, and that will give me 678.6 centimeters squared. And the last one right here, same thing. To do my surface, it's pi r L plus pi r squared. So my radius would be 10. My slant height is 26. So pi 10 times 26 gives you 816.8. And pi 10 squared gives me 314.2. So my answer would be 1,130. Actually 1,131.0 millimeters squared. Okay, on the back side is when we're talking about spheres. We're talking about spheres is the locus of all points. That means I take one point, I go a certain distance, and no matter which direction I go, that's what will create the sphere. So a radius, again, is still from the center to the edge. A great circle, so if I take a circle and I cut it straight in half, the largest point is called the great circle. So as I get further and further away from the center of the circle, that circle cut would be smaller and smaller. So if I slice it, I do the cross section right in the middle, that's called the great circle. And it doesn't matter where I put my great circle as long as it's at the longest point. So there's lots of great circles that it could be. And then if I cut a sphere in half, then I get a hemisphere. And that's kind of like what you talk about in history, the northern hemisphere, the southern hemisphere. If I cut a circle in half, that's when I get a semicircle. Okay, so don't get those confused. And then we talked about cutting and doing cross sections of a circle. Well, I can cut a circle at a point if I just go right at the very bottom. I can get a circle if I just slice it, and then I can have a great circle if I cut it straight in half. So now let's talk about the surface area of a sphere. So the surface area of a sphere is 4 pi r squared. So right here, this would be 4 pi 6.5 squared. So 4 pi 6.5 squared will give you 530.9 centimeters squared. This one here, 4 pi, well, let's see, 89 is my diameter, so I have to cut that in half. So it's 44.5 squared, 4 pi 44.5 squared, and that would be 24,884.6 feet squared. Number 3, it says the sphere with an area of a great circle is 29.8. So remember, a great circle is the largest one, and it says it has the area. So area of a circle is pi r squared. That area is 29.8, and that is equal to pi r squared. I would divide by pi. So 29.8 divided by pi gives me 9.49. And then I'll have to take the square root of that, which would give me 3.08. So that would tell me what my radius is. But they want us to find the surface area, which is 4 pi 3.08 squared. So 4 pi 3.08 squared. And that'll give me 119.2 meters squared. And then on this last one's a little tricky if we're talking about surface area and we're cutting a surface sphere in half. Because a lot of you would think that all you would do is divide that in half. So 4 pi r squared is my surface area. And a lot of you would say, well, I can just divide that by 2. Well, in a way that's true, except when you slice that hemisphere, not only are you going to keep this round section here on top, that's just half of that, but what you have to think of is when you made that cut, you exposed this circle right here. So now I have a circle bottom. So I need to add to it pi r squared, the area of this red circle. Well, let's look at this for just a second, Because really what happens, what's 4 divided by 2? So this makes it 2 pi r squared. Then I need to add pi r squared. Well, isn't that 1 pi r squared? So that means I'm really just going to do 3 pi r squared. So I have 3 areas of a circle that I'm going to do just for that one problem. And I don't remember what it said for its radius was 6. So this will be 3 pi 6 squared. I'm not sure where I wrote a 3 right there. So 3 pi 6 squared would give me 339.3 centimeters squared. Okay. Well, that is all for today. Have a good one.